Statements in this presentation that refer to future plans or expectations are forward-looking statements. These statements are based on current expectations and involve many risks and uncertainties that could cause actual results to differ materially from those expressed or implied in such statements. For more information on the factors that could cause actual results to differ materially, see our most recent earnings release and SEC filings at www.intc.com.
What if every system moved in perfect sync? Seamless, unified, alive. This is orchestration in motion. Intelligence at the core. Systems thinking ahead, personalizing every moment, creating a cabin alive with possibilities. Power flows smarter. Seamless energy management boosts performance, optimizes efficiency, and keeps you moving. Flexible intelligence adapts on demand. Software-defined zonal controllers balance every system effortlessly for a seamless drive. Intelligence unified. Next-gen architecture with AI inside enables software reuse across product lines, accelerates innovation, and lowers total cost of ownership. With the flexibility to add new services and software once the vehicle hits the road, automakers can optimize today and stay ready for what's next. Intel, engineering the art of possible.
Please welcome Intel Fellow, Vice President, and General Manager, Jack Weast.
Thank you. Thank you, everyone. It's really an honor to be here again speaking with you. The automotive industry continues to go through significant change. And my simple message here for you today is that Intel is here to help. So I want to recap briefly what we talked about last year. We talked about that the transition to software-defined architectures is a significant opportunity, but also a challenge. And this is a place where Intel can help, because Intel understands software-defined architectures. We pioneered them in the data center, and we've been adding silicon features ever since. And we've helped other industries transform from telecommunications to industrial manufacturing. And so we can help do the same here in the automotive industry. We also talked about how electric vehicles need to become more sustainable, not just environmentally, but also economically, so customers can make a profit on these vehicles. And Intel knows something about this as well. You might remember those early mobile computers, huge batteries, very small battery life, much like electric vehicles today. But Intel started focusing on the efficiency side of the equation and introduced advanced power management techniques that give us this all-day thin and light batteries that we enjoy today. So once again, Intel is here to help. And finally, we highlighted the challenge for a more scalable solution that matches the price, performance, and power needs of automakers. And this is why Intel has doubled down on chiplet-based products in our automotive roadmap, giving our customers an opportunity to bring their chiplets, their intellectual property, into an Intel roadmap product. It's a game-changing opportunity for the industry. So all of this remains true from last year. But in the last year, competition has gotten fierce. Profits have become more elusive. And so we can't keep doing the same thing and expecting a different result. And so today, following our successful acquisition of Silicon Mobility that we announced last year on this stage, I'm very proud to introduce Intel's whole vehicle architecture approach. This is a system-level view to the vehicle architecture that focuses on 3 elements to reduce cost and advance the architecture. They are high-performance software-defined central compute solutions, ECU consolidation with software-defined zonal controllers, and electric vehicle powertrain solutions. All 3 of these sockets in the vehicle are now offered by Intel Automotive. And by taking a whole vehicle approach to re-architecting the vehicle, the industry can fully capture that potential of cost savings, energy efficiency, and leading node innovation that consumers want. So where do we go from here then? So as the old adage goes, sometimes we miss the forest for the tree in front of our face. And so with that, I'd like to take a step back and ask, what really is a software-defined architecture? We hear it all the time. It is not over-the-air update. You could absolutely update a car over the air without embracing a true software-defined architecture. Software-defined is a mindset. It's an architectural philosophy that abstracts hardware from software so that hardware resources across multiple sockets can be pooled of compute and memory and I/O. And then when a workload comes along, you allocate a platform from that pool that matches the priority or policy needs. So for example, it might be throughput. Perform that workload as fast as you can. It might be perform it at the lowest cost. So in a data center, that might mean run the workload at night. Or it might be determinism. Run this workload to complete at exactly a specified time. The net result is multiple different virtual platforms allocated from a common resource pool that a system designer can then use to run multiple concurrent workloads. And so where did this all come from? It started in 1972 with IBM. The first time hypervisor concept was demonstrated that abstracted the hardware platform from software. But really, we've got to fast forward to the 90s. And it wasn't until Intel architectures started showing up in server and data center applications. And then we had this growth of open source software, starting with Red Hat Enterprise Linux. And then the growth of additional container frameworks and hypervisors and orchestration frameworks, all happening with silicon features that Intel was adding along the way. We first added VTX, virtualized the CPU. Then we added VTD, which added I/O protections for virtualization. Then we added SRIOV, single root I/O virtualization, that virtualizes PCIe devices. So you see, for 20 years, Intel's been adding silicon features to Intel architecture to do software-defined right. And none of these features, to be clear, come from the phone and tablet world. These come from the x86-based data center. And only Intel Automotive fully supports these features in our automotive roadmap. And these features matter. So let's take a look at just one, SRIOV, as I mentioned, single root I/O virtualization. So what we've done is we've taken Android and we've put it inside a virtual machine running on top of a hypervisor. And we ran an industry performance benchmark called Manhattan 3.0. It's publicly available. You can go get it. With SRIOV enabled, you get 99% of bare metal performance with a variability of only 95 to 100%. So with these silicon features, you get bare metal performance while embracing software-defined and virtualization. If you don't have this feature, your performance drops. On average, only about 43% of bare metal, and worse, variability from 20 to 90%. And you've probably experienced this, maybe in cars that you own. You swipe the screen, sometimes it's smooth and fluid. Sometimes you see some jitter. This is what's happening. Behind the scenes, this is what it looks like. Without support for SRIOV, you have to fake virtualization in software. So you have to add huge software overhead in a software-based virtualization model. So all the graphics commands hit the hypervisor and bounce up to the service OS, and then you've got a single pipe bottleneck to get to the hardware, because the hardware supports only a single physical function. This is also a security target. It's also a safety threat. What if that real-time operating system needed access to the hardware resources to perform a safety-critical function? You could have a denial of service attack within your system to prevent that from happening. And this is why in Intel Automotive Silicon, we support SRIOV. The silicon supports virtual functions that can be allocated directly to virtual machines, which not only provides that bare metal performance, but provides silicon-enforced separation of these workloads, which is absolutely essential when you run in mixed criticality workloads. So even if you could improve this by tweaking and growing and improving your software virtualization model, as long as it's software-based, you don't have that silicon-enforced separation. that's essential for these kinds of workloads. So don't take this from me, though. Let's hear from a friend of ours. Francis, please welcome to the stage. Hey, Francis, welcome.
Thank you, Jack.
So, Francis, Red Hat knows a little something about software-defined, I think. So what does this journey look like to you?
Well, for those who are not familiar with Red Hat, we are the largest open source company. It all started 30 years ago when we decided that instead of filing patents to support expensive proprietary products, open collaboration was the best way to create software. Today, over 90% of cloud servers are running on Linux. Since Linux is constantly evolving, it is standing at the cutting edge of software technology. And it has enabled many industries to move from hardware-defined to software-defined.
So it's clear Red Hat knows software-defined, but I think it's clear. Let's state the obvious. A car is not a data center. So how do you go from Red Hat Enterprise Linux to something that can be used inside the vehicle?
Well, Jack, you are absolutely right that the car is not a data center. There are a few key differences, including real-time, fast boot, and of course, functional safety. In fact, more than a few automakers and suppliers have tried to safety certify Linux previously, but so far without much success. With our long history in Linux, supporting mission-critical IT applications, we are bringing our expertise and know-how to the automotive world.
So in fact, I think you just made a huge leap forward in this journey, if I'm not mistaken, right?
Yes, I am very happy to share that we have just received an ISO 26262 ASIL-B functional certification on several key Linux subsystems that enable mixed criticality. We are still on track to get to full product certification within this year. Mixed criticality means that we are able to isolate safety and non-safety applications such that we can run both concurrently on the same operating system. This brings dramatic improvement in software system architecture, resource utilization, design, testing, and deployment without compromising any safety concerns. This is how we would enable true software-defined vehicles. The resulting productivity gain, cost savings, and future scalability are exactly what the industry needs, especially since it is going through some recent economic challenges. This is the time to leverage technology to help address these challenges.
That sounds great, Francis, and that's why I am thrilled to announce today that Intel and Red Hat are working together to bring Red Hat's in-vehicle operating system to a car near you with Intel inside. With over 30 years of history, thank you. With over 30 years of history and expertise on Intel architecture, the combination of our two companies will help bring true software-defined architectures to the automotive industry.
That's right. The fact that Intel Automotive's roadmap supports the same silicon features for hardware and for separations that Red Hat has been supporting for decades in the data center will allow us to offer the automotive industry a proven solution for embracing software-defined architectures.
That's fantastic, Francis. We're grateful for your support and thrilled to see Intel and Red Hat working together.
Thank you, Jack.
Thanks, Francis. Okay, so last year, we announced our first generation family of AI-enhanced software-defined vehicle SoCs. But a lot has happened in this year. I think it's safe to say that we've entered the AI cockpit era. With AI-enabled PCs in our homes, consumers' expectations are changing. Again, to expect, if not demand, that their cars feature the same kind of AI capabilities they're enjoying on other devices. And so whether it's the growth of large language models, increasing demand for AI PC-like gaming in the vehicle, or the desire for automakers to differentiate their in-vehicle experiences, a theme we've heard over and over again is that our customers want more. They want more compute, more AI, and more graphics so they can do even more inside the vehicle. I think many of you know, I'm currently based in China, and so last year, we launched our first generation ARC graphics for automotive, and the response from the ecosystem has been phenomenal. 3 quick examples. Baichuan, an AI chatbot for kids. Have a long car ride? Let your kid have a multi-hour, real-time, natural conversation with a storytelling character that will keep them entertained for the entire drive. RiSound, an AI business assistant for the busy business person who's constantly on calls and meetings in the car as you're driving around town. It will automatically summarize the meeting content, identify speakers, and keep you on track as you go about your day. Or Jeepu, an AI car assistant that uses Intel AI for intent recognition and action execution to quickly respond to driver or passenger needs. These are 3 examples of many in this growing ecosystem of AI-enabled applications for Intel Automotive in the car. And so with this significant head start, I am now very proud to announce Intel Arc B series graphics for automotive. Commonly known as BattleMage, this features over 200 TOPS and up to 12 megabytes of onboard memory. This incredible chip will allow automakers to run an entire large language model inside the vehicle, completely eliminating that annoying cloud latency when asking a question and waiting for a response. With in-vehicle gaming growing in popularity, there is no better gaming experience than what you get on the PC. And so with BattleMage in your car, you can now enjoy AAA PC gaming in many new vehicles that will be on the market soon. Have kids that need to be entertained? As I said before, have AI-generated content. Keep them entertained for hours. And finally, I think we're all sensing it's time to level up that visual experience inside the car. This old 2D phone, tablet kind of UI is getting old. It's time to do something better. So why not upgrade to a 3D visual experience driven by the most advanced 3D engines from the PC ecosystem with SRIOV support built into the silicon? And so that's why I'm particularly pleased to also share that automakers will soon be able to use Epic Games' Unreal Engine 5 on BattleMage to develop incredible experiences inside the vehicle. This is the same engine that you enjoy on your PC that delivers those incredible game experiences and those gorgeous visuals. So from the outset of Unreal Engine's development from the mid-90s, Epic has been consistently pushing the envelope for real-time 3D computer graphics on Intel hardware. And automotive was actually one of the first industries to use this engine outside of games. And so again, with consumer expectations changing, there's a strong appetite for richer in-car experiences, and that's exactly what the Unreal Engine brings to mobility platforms. So we are working directly with Epic to ensure that the Unreal Engine runs great on BattleMage, which is now coming to vehicles. So what does this mean in real-world performance? It means faster graphics, smoother displays, the ability to get more out of your hardware. And so many of you know, as I said, I'm currently based in China, and there's a very popular performance benchmark out there called Antutu. And so many of our customers are using our silicon to do incredible things. So if you look at the chart behind me, this is a popular Android performance benchmark, and our first generation family of AI-enhanced SDV SoCs has just recently taken the top 2 spots, beating all other commercially available solutions in their automotive performance benchmark by almost 3 times in that #1 spot of our nearest competitor. So this is what it means to bring Intel class performance to a vehicle and to give customers the ability to do more and bring their visions to the market. And so it's not just about software in the vehicle, though. It's also about software in the cloud, and in particular, development in the cloud. Traditional embedded development's expensive, and it's time-consuming. Developers and validation teams need access to large volumes of physical platforms to do their development. And so when an automaker wants to reduce cost, we need to think not only about the vehicle architecture, but we also need to consider the R&D cost to develop the vehicles themselves. And so with in-vehicle development moving to the cloud, it's a great way to kind of shift left your development lifecycle. But there's a problem. All the advanced development in the cloud is no good if you have no idea how that software is going to actually run on the in-vehicle silicon. And so to learn how the power of Intel architecture can uniquely solve this problem, I'd like to bring out a friend and partner to share more. Rob, please join us. Thank you for being here, Rob.
Thank you so much. It's exciting to be here today.
So Intel and Amazon Web Services, we've got a partnership that stops at the top and covers a lot of different industries. But we're here to talk about automotive, my and your favorite industry. So why don't you say a little bit about AWS's automotive offerings?
Thanks, and thanks for the opportunity again. AWS, we understand the challenges faced by automotive developers, and that's why we've built tools and services to help these developers. AWS supports the automotive value chain from product engineering and design to software-defined vehicles to manufacturing and supply chain, and finally to the customer experience. Our AI and Gen AI services also help our customers deliver new experiences to their customers and help developers accelerate time to market.
So, but you're here for a very specific reason, right, Rob?
I am. Today, we are thrilled to publicly announce our collaboration with Intel Automotive, where we can offer a game-changing virtual development environment that features the same silicon that automakers will deploy in their cars.
I love this, Rob. So please tell us how you're doing this.
This new innovative approach is called the Intel Automotive Virtual Development Environment on AWS. It's a comprehensive end-to-end approach to achieve environmental and functional parity for automotive software development. Because software,
excuse me.
when you need, functional and performance testing is important when we do software development. You need to do performance testing. You can seamlessly transition to an environment enabled by Intel Automotive SDV SoCs that delivers performance parity with in-vehicle platforms. This way, we can access the right hardware and tool chains in advance of vehicle testing and shift left the development cycle.
This is great, Rob. So as a former developer, I'm curious how the development experience is going to change. Can you give us a preview of that?
Yeah, let me walk you through an example. Let's say you're a software developer working on an electronic mirror application. You want to start developing as early as possible. For this, you can easily set up existing AWS EC2 instances powered by Xeon to develop and test this functionality, and you can do this at scale. Depending on your use case, this functional environment might be good enough. But for some use cases, developers need to confirm the in-vehicle performance. The best way to validate this is by having access to the performance test environment with the same hardware and SoC in the cloud that's also in the vehicle. By enabling the Intel Automotive SDV SoCs in the AWS environment, the developer will now be able to check both the functional and performance of this electronic mirror application.
Mm-hmm. So Rob, this is awesome. I would imagine this should also result in some pretty significant cost savings for developers. I remember I used to be a developer myself at one point, and I remember hours in the lab in evenings and weekends because that was the only place you could get to that target hardware platform. But if I'm understanding you correctly, with what you've described, if you've got Intel in the vehicle, that same silicon can be in the cloud, which means all those target platforms and all that mess of wires is going to be the thing of the past, right?
That's right. So what it means is that the early hardware with all the cables and peripherals you used to have on every developer's desktop can move from this to now this, which enables remote access to the hardware in the cloud is almost identical to that in the vehicle, allowing for a consistent developer environment and early testing for performance.
Mm-hmm. This is amazing, Rob. So when can we get it?
Now. Check out our joint blog post on aws.amazon.com.
That's fantastic. Thank you, Rob, very much.
Thank you.
Thank you. All right, so you've seen what Intel is doing to advance and accelerate the transition to a software-defined architecture for both developers and passengers alike. So let's now transition to how we're helping the industry reduce energy costs and increase the energy efficiency of electric vehicles. And here, the industry has a problem. By 2030, it's estimated that the demand for lithium carbonate will be over 50% greater than current supply estimates. If you extend that to 2050, things get even worse. And so this is happening not just because of the growth of EVs. It's happening because battery sizes are getting bigger and bigger and bigger. And so at Intel, we know a little something about this. Remember those early mobile computers? How big and heavy those batteries were and how short the battery life was? just like EVs today. So it's time we started focusing on the efficiency side of the equation, just as we have done in the PC world. So let's understand the source of the problem. Consider an electric vehicle's powertrain. With 100% theoretical energy coming in, that flows through the onboard charger, then it gets into the battery, goes through a DC to DC converter, then you've got an inverter that finally delivers energy to the electric motor. By the time you're done with that energy flow, you've lost almost 40% of that theoretical energy that was coming in. And these losses come in the form of heat that needs to be managed and dissipated. And so if we could make this process more efficient, we could capture that wasted energy, reduce losses, and reduce cost. So let's dive further into the source of this problem. The core issue is the algorithmic approaches that are being used in the industry today, things like space vector pulse width modulation. This modulation technique could have never imagined the size and voltages of batteries and e-motors that we have today. So many in the industry are moving to silicon carbide as a way to gain efficiency, but still using that same modulation approach. But there are better approaches. Things like optimized pulse pattern, which is a modulation technique that's not time-based, but is actually based on the angular rotation of the motor as it's spinning, so ensuring much more accurate delivery of energy as the motor operates. And so if you move to a different modulation technique, you can get even greater benefits than even moving to silicon carbide. So if this is so beneficial, then why isn't the entire industry doing this? Why isn't everybody using advanced modulation techniques like optimized pulse pattern? Well, it's because just like AI algorithms require new kinds of compute, so too do new kinds of modulation algorithms like optimized pulse pattern. And traditional automotive microcontrollers and DSPs simply do not have enough horsepower to run these algorithms. And so let's consider why. In a traditional microcontroller architecture, when an acquisition signal comes in, it's dispatched from a timer processor to the CPU or DSP, then it goes back out. This is a sequential processing flow through the chip. So meaning it's generally not possible to process another signal if it comes in while you're processing the current one. So many have tried to solve this problem by adding more CPU cores, but then the more CPU cores you add, the worse your latency problem gets, and this leads to non-deterministic performance of safety-critical workloads. So the problem here is that this humble microcontroller that's been with us for over 50 years has simply run out of gas. And so don't you think it's time for something new? And that's why I am thrilled to announce today a completely new kind of compute device for the automotive industry, the adaptive control unit. This is a microcontroller for the software-defined age. Unlike traditional microcontrollers or DSPs, the adaptive control unit is able to put 95% of that real-time control logic into the hardware, into a flexible logic unit, which is a programmable portion of the chip that's specifically designed for real-time control algorithms. With an adaptive control unit, when a signal comes in, it's processed immediately and deterministically, and you can process hundreds of these events simultaneously with the same determinism guarantees on each and every event. This control unit thus allows for new kinds of control algorithms like optimized pulse pattern. You can programmatically embed it in hardware, not software, and this can result in data processing up to 1,000 times faster than traditional approaches in a fully deterministic manner, completely independent of CPU load. What are the benefits to an electric vehicle powertrain inverter? They are incredible. Energy efficiency at each stage is improved by up to 5%, allowing automakers to reduce the size, weight, and cost of their cooling solution. For an electric vehicle inverter alone, simply changing to an adaptive control unit can net an immediate $40 to $70 BOM savings per vehicle. And that does not include the cost savings of shrinking the motor by 25%. Because the motor's operating more efficiently. or shrinking the battery voltage or reducing the battery voltage by 20% and still getting the same range. So this is what it means to focus on the efficiency side of the equation. There's so much that we can do in the industry to deliver greater efficiency and lower costs of electric vehicle platforms. So why take it just from me, though? Let's hear from some real customers who are seeing these benefits firsthand and delivering another level of performance. Let's roll the video.
At Stellantis Motorsport, we are developing electric powertrain to enter the FIA Formula E Championship. Our challenge is to continuously improve our performance and to fight for the top spot of the podium. This partnership is a testament as well to our shared vision for the future of electric mobility. Intel Automotive has a huge expertise in high-performance semiconductor solution, so I'm very confident that we are going to have one of the best next-generation inverter control. It is a critical component of the Gen 3 Evo single-seaters of DS Automobile and Maserati, in charge of controlling the electric motor using energy from the battery, but also recovering energy during the braking phase. The inverter plays a crucial role where any gain in efficiency is transformed into competitive advantage in a race. I'm very excited about this technical partnership with Intel Automotive. This new inverter control leverages Intel's advanced semiconductor technology and software expertise to optimize power delivery and enhance overall vehicle performance.
E-Motors is a joint venture established in 2018 with the mission to design and manufacture electric drive units for the rapidly growing e-mobility market. Our latest innovation, delivering 80 kW at 100 volt, is one of the most compact and competitive in its category. This achievement has been possible thanks to technical solutions that enable speed exceeding 20,000 RPM, like few other technology leaders, and at the same time maintaining high efficiency. This is why from the outset a natural synergy emerged between E-Motors and Silicon Mobility, now Intel Automotive. The processor developed by Silicon Mobility features a unique characteristic. It reduces the cost per kilowatt, and at the same time it increases the energy efficiency of the electric drive unit. This technological breakthrough enables E-Motor to pursue its vision of offering competitive electric powertrains while further improving efficiency and consequently vehicle range. Currently, we are testing this Intel Automotive processor on Stellantis Motorsport Formula E with the aim to implement this technology across all electric vehicles equipped with E-Motors drive units.
So battle-tested and bulletproof. Thank you. Battle-tested and bulletproofed in the most demanding performance environment, but with the scalability to benefit everyday passenger vehicles just the same. This is the power of the adaptive control unit. But the benefits don't just stop with energy efficiency. You know, history is full of happy accidents, when inventions created for one purpose ended up having an entirely different use in other contexts. So we all remember the telephone, right? Alexander Graham Bell invented the telephone. He didn't actually. His patent was for a harmonic telegraph. He was trying to find a way to send multiple telegrams across a single wire. And he only later realized that our voice has harmonics, so why not send voice over a wire? So, same also with the radio. Popularly, Marconi invented the radio. He did not. What he invented and patented was a wireless telegraph, a way to send telegrams again over the airwaves. And so as he was receiving messages from the Titanic over telegraph, and it was sharing that news with the world, he suddenly realized we could send voice and use this as a form of entertainment. Or who remembers 3D wallpaper? In the 1960s, this was the latest and greatest interior design invention. Completely failed to take off, but was used, importantly, to package the IBM 1401 computer in its first use as packing material, which we now, of course, know as bubble wrap. So the lesson in all of these examples is that when inventing a solution for one purpose, sometimes you end up creating something even more powerful and useful in other contexts. And that's exactly what we have done with the adaptive control unit. What started as a purpose-built solution for electric vehicle powertrain applications has applicability far beyond that original context. And it's because the fundamental properties that differentiate the adaptive control unit from a traditional microcontroller are exactly the pain points that automakers and tier 1 suppliers face when they start consolidating multiple microcontroller workloads onto a single domain or zonal controller. What you want is a single chip where you can combine multiple ECUs into one. What you need is freedom from interference. Because of our flexible logic unit, as I described, from pin to processing all the way back out to pin, complete silicon-enforced separation of those workloads for freedom from interference by design. And finally, it's adaptive. What that means is in the field, post-deployment, or even as part of your design flow, the same chip can support multiple different topologies and can be reconfigured real-time on the fly. This significantly simplifies the supply chain, lowers development costs for both development and deployment. And so, with the expansion of the Intel Automotive portfolio that we've announced today, Intel Automotive can now address these industry challenges with a whole vehicle architecture. A whole vehicle approach fully embraces a software-defined mindset, not just in one socket, but across the entire vehicle. And that's when significant cost savings can be achieved and the vehicle architecture can finally take a giant leap forward. So with 3 distinct product lines co-designed together, we offer an architectural foundation for innovation. These are the 3 most important sockets for cost savings, and we offer now a comprehensive offering unmatched in its scale of performance, from a power controller to zonal controller to the highest performance software-defined vehicle SoCs. So why would you want to take this approach? Let's look at a couple simple examples. So if you have a software-defined zonal controller and a software-defined central compute platform, why not move workloads back and forth between those sockets, just like we do in the data center, where software-defined comes from? So let's say a feature like Sentry Mode. For anybody who has an electric vehicle, you've got a Sentry Mode feature. When the car is off, your e-mirrors are looking for activity. Maybe somebody's going to steal the car. Maybe it wants to recognize you to unlock the car. Today, that workload runs on that in-cabin central compute system, which means you're burning 40 to 50 watts of energy 24/7 while your vehicle's off. Why not instead move that workload to a 4-watt zonal controller, turn off that high-performance compute system, wait for activity. When you see activity, move the workload back, wake up the big system, and continue processing. It's a simple example of what a true software-defined mindset means. The benefit here was energy efficiency, but the concept is universal. Workloads can now be moved at will from socket to socket by fully embracing a software-defined concept. So what about energy? Energy management subsystems is typically completely separate from the rest of the vehicle. What if from observed behavior, you know the driver on this route only uses about 50% of the e-motor's full capability? Why not share that information with the power subsystem? Tell the e-motor drop to a 50% efficiency mode, tell the battery lower the voltage, and capture all those energy savings. This is what we've been doing in PC platforms for 20 years. Dynamic variable voltage scaling based on actual workload needs. This is a big contributor to why we enjoy these thin and light all-day PCs that we have today. So think what those innovations can do from an energy savings and cost savings standpoint to an automaker building an electric vehicle platform. But why not stop there? What if we extended these concepts to the entire vehicle? If it's winter in Detroit, why is your air conditioner ECU powered? Today it is. If it's summer in Phoenix, why is the seat heater ECU powered? Today it is. If you're at a long stoplight or you're charging your electric vehicle, why is the ADAS ECU powered? In today's vehicles, it is. It's a waste of energy. So why not intelligently turn them off, even predictively, and deterministically wake them up. So by considering the whole vehicle as a platform that can be managed, the energy and cost savings benefits are immense and they're real. So I hope you can see the benefits of taking a whole vehicle approach. And we are proud to be the only supplier that can offer not just the highest performance AI-enhanced software-defined SoCs, but also EV powertrain and zonal controller devices for the software-defined age. We want to help the industry solve its biggest challenges. And so to gain further perspective on the value of Intel's whole vehicle architecture, I'd like to welcome Jeffrey Hanna from SBD Automotive. Jeffrey, come on out. Welcome, Jeffrey.
Hey, Jack. Good to be here and great to talk about Intel's whole vehicle architecture. As way of introduction, SBD Automotive is an industry-leading mobility research firm. We work with 80% of global automakers, helping them deliver safe, secure, sustainable, and seamless automotive outcomes for their consumers worldwide.
So thank you for your support, Jeffrey. There's a lot of talk in the industry about moving to software-defined architectures, and there are some obvious direct benefits in doing so, but not all software-defined architectures are created equal. So help us understand the difference from your perspective through your research, the difference between Intel's whole vehicle architecture versus other software-defined approaches.
Jack, great question, and we broke it down. We did an independent evaluation from SBD comparing Intel's solution to a distributed legacy automotive architecture that's all too predominant in the market today. The benefits of moving to an SDV architecture are clear. You can see some of them here on the screen. 80% reduction in ECUs, 60% reduction in wiring harness length, and another 35%, you talked about power consumption reduction overall. Yeah. But we also found that with Intel's approach to the adaptive control unit and the whole vehicle architecture delivers benefits really across the full vehicle life cycle. For example, one thing that's unique is that you can update hardware algorithms. And by doing that update of the hardware algorithms, that gives you an additional 54% hardware utilization. Wow. With a 43% additional energy reduction to all those great things you talked about, Jeff.
That's huge, Jeff. And I'd imagine that contributes significantly to accelerating the time to market for vehicles as well, right?
Definitely. I want to talk just for a second about the ability to have cloud updates with your SoCs as well.
With AWS.
Before I forget.
Yeah, go for it.
With your AWS announcement. The ability for automotive SoCs to be accessible from the cloud really gives you a 15 to 20% reduction in overall platform development time, which is key to market competitiveness. So speed is the key.
That's fantastic.
When you think about, one of the big problems, it's really that automotive software validation. OEMs are great at hardware validation, but software validation is hard stuff. So platform optimization is traditionally very, very time consuming, but we estimate that a full 45% reduction in validation time is possible with Intel's approach. So extend those benefits across the vehicle life cycle, you're likely to see less warranty repairs because of the upgradability of the adaptive control units, as well as enabling new software-defined consumer experiences overall. So it's a win-win-win.
Awesome, Jay. Thank you. When we created this whole vehicle architecture, we really believed it would provide significant additional benefits to the industry, and it's really wonderful to see your analysis prove that out. So at Intel, we like to say there's software-defined, and then there's software-defined done right that delivers the true cost savings opportunities while providing that foundation for innovation. So thank you again, Jeffrey, for being here.
Thank you for having me.
Thank you. So it is one thing to hear this from a respected industry analyst, but it's automakers who we're trying to help. So let's hear from a car maker who is fully embracing Intel's whole vehicle architecture. It is my honor to welcome to the stage Marcus McCammon, President of Karma Automotive. The wardrobe malfunction, huh? Hey, Marcus, how you doing?
Good, how are you?
Good. So, why are you so excited about, before we talk about the whole vehicle architecture, I'm sorry. For those that don't know Karma Automotive, you need to know about this company. So, Marcus, why don't you share a little bit about what you're up to?
Thanks, Jack. So, Karma Automotive is America's only dedicated full-line ultra-luxury vehicle manufacturer. All of our vehicles are designed, engineered, and manufactured right here in the US, but to be specific, in Southern California.
I love that. You know, and if you've not seen one of these vehicles, I can personally attest they are absolutely gorgeous. So, but tell us why you're here.
Yeah, so I'm excited to announce that Karma will be implementing the Intel whole vehicle architecture, SDV architecture, on our Karma Kavea, our 1,000 horsepower, all-wheel drive, 0 to 60 in less than 3 seconds super coupe, slated for production in late 2026.
Love it.
And to give, thank you. And to give a little bit more context to the collaboration, that inverter right there is the actual hardware that our engineers are developing right now, featuring this architecture for that vehicle.
That's fantastic. And so this is real.
This is real.
It's going into a real car.
It's going into a real car.
That's fantastic. So tell us what it means about this ground-up software-defined vehicle architecture approach.
Well, the thing for us is we think that we have the opportunity to be the very first manufacturer to deploy a full ground-up true SDV architecture. And we'll do that with the Karma Kavea. It will have the ability to have workloads redistributed, be updated via the cloud, and it will serve as the platform for every Karma vehicle going forward.
That's awesome. You know, but I think you're not stopping there. You know, like Intel's commitment to open platforms and open architectures, you're dedicated as well to making this transition in a way that could help the entire industry, right?
Absolutely.
Yeah.
You and I have shared this vision since about 2014. From Karma's perspective, we don't believe that it makes sense for SDV architecture to be wholly proprietary. That approach is slow, it's cost prohibitive, and frankly, it threatens the integrity of the entire industry. We want not just Karma, but the whole auto industry to succeed, to provide a foundation for the advancement of open standards and SDVA. Foundational capabilities do not and should not be proprietary because they're not really consumer differentiable. They should be shared. And just like the history of USB, there was another brilliant Intel fellow by the name of Ajay Bhatt. Ajay had the idea that there should be one connector to link all devices. What started off as a mission to connect devices to PCs has evolved into a ubiquitous connectivity model for all devices in all form factors that delivers communication as well as power. So we think about SDV in that same context. Karma will be a living development prototype for the broader industry, as we ally for the development, acting as a development partner at scale, so that our technology solutions can ultimately provide a gateway to the rest of the industry.
That's fantastic, Marcus. I mean, I think this is truly exciting and transformative. I'm so excited to do this with you. To be honest, I'm not sure if I'm more excited to own a Kavea Super Coupe or just help the industry do software-defined done right.
Well, how about you do both?
All right.
And then we'll invite the rest of the room to do the same.
All right, deal. Thanks again, Marcus. I appreciate
a lot,
you
Jack.
being here. Congratulations. So technology alone, though, is not going to solve all our problems. The industry is facing incredible economic pressures, just at the time when it needs to be making significant investments and advancements in vehicle architectures. Skill set challenges exist, because data center expertise in virtualization and orchestration and containers and AI frameworks, these are not traditionally found in the automotive industry. Many automakers also want to develop their own silicon. Most have never done so, let alone on a leading silicon node. And so at Intel, we recognize these challenges and we want to help. And so that's why I'm thrilled to announce a first-of-its-kind collaboration with HCL Technologies that will combine the industry-leading technology from Intel Automotive with industry-leading professional automotive engineering services. And so with that, let's welcome Amir from HCL to the stage. Welcome, Amir. I'm thrilled that you're here.
Thank you, Jack.
So for those that aren't familiar with HCL Technologies, why don't you take a few moments and share a little bit about your company?
Thank you, Jack. First of all, it's a privilege to be here. Thrilled that we get to collaborate with Intel for the future of automotive. Thank you. HCL Tech, we bring 30 plus years of engineering excellence. We are a team of more than 200,000 engineers. Amongst them, 45,000 plus are R&D experts. How we consider ourselves is we are the digital solutions provider, from chip to cloud.
Love it. So to my recent memory, I can't think of a time when a technology company and a professional engineering services company have come together in such a way to advance an entire industry's goals. So what does it mean for you, from HCL's perspective, for us to come together like this?
Absolutely, I couldn't agree with you more. It is unique. We are combining two industry-leading capabilities. Intel's automotive leadership, HCL Tech's deep engineering expertise, and this is needed. This is needed for customizations and systems integrations. What we are trying to do, we are aiming to address the critical needs of OEMs and Tier 1 suppliers to accelerate their move to software-defined vehicle, and which means accelerating transition to highly efficient EVs, and of course, software-defined mobility. To me, this is about combining best of both worlds of innovation and execution.
So I hear you talk about sometimes this spec to chiplet concept.
Yeah.
And at Intel, we have fully embraced chiplets in our automotive roadmap, and we'll be delivering automotive-qualified chiplet-based products to the industry. And one of the unique capabilities we offer is for our customers to bring their own chiplet to be integrated into an Intel roadmap product. So how can you help with that?
Yeah, I think the future is chiplet-based, just like you do. The way I see it, there are two things. One is that HCL Tech has an offering, which is the spec-to-chiplet offering that you referred to. Here, we take responsibility and help our customers develop their own chiplets much easier than in the past. Secondly, integration. What we are looking for is an ability for each of our customers to be able to put a stamp of their own, which is where we help them integrate their own chiplets into Intel's roadmap. Now, this is how we will drive advancements in high-performance computing and AI and things like that. Yeah.
That's fantastic. But I think there's more than silicon. What about software? That's a huge challenge for the industry,
absolutely,
right?
Absolutely. Of course, HCL Tech brings unmatched software expertise across the spectrum. Specifically in automotive, multiple areas, Android-based automotive software, Google Gas certifications, et cetera, et cetera. Now, all, of course, with seamless integration to Intel platforms. Now, we are also simplifying porting, and we believe that is a big industry challenge, where there are existing solutions, SoC solutions, that need to be ported to Intel. That is also something that we are investing in. What we are aiming for is, essentially, it is a flexible, reduced risk of lock-in for our customers, and at the same time, accelerated time to market.
That's fantastic. I mean, to me, it seems like this is kind of an easy button, collaboration model for the industry. So Intel provides the right technology platform for a software-defined future, and HCL Technologies brings all the engineering expertise and services to accelerate time to market and lower R&D expenses. So not just end-to-end, but from zone to HPC and from the car to the cloud. So I think this is fantastic, and my thanks again to Amir for being here today.
Thank you very much.
Thank you, Amir.
Thank you.
Okay, so I'd like to close and revisit what we announced today. We announced new products, including our high-performance Intel Arc B-Series graphics for automotive. We announced a new kind of compute device, an adaptive control unit for not just electric vehicle powertrain, but for broad zonal application use cases as well. And we've combined all of this into a whole vehicle architecture that provides a foundational platform for innovation and cost reduction. And with incredible partners like AWS, Red Hat, HCL Technologies, customers like Stellantis Motorsport, eMotors, and Karma Automotive, we are all together paving the path to a future vehicle that is software-defined, sustainable, and more scalable than current industry approaches. But we're doing this in a way that emphasizes not just innovation, but also cost reduction to help the industry through this challenging period in its rich history. So in summary, we are here to help. Intel is committed to delivering what the automotive industry needs, and much of what you heard today is a result of the direct feedback that we have heard from you, our customers. So I'd like to thank you all again for being here. Please join us next door at the Technology Showcase to see much of the technology I talked about today being demonstrated live and in person. The Intel Automotive team will be there, so come join us, find us, and give us your feedback. We want to help. We are here, and we are listening. So thank you very much for coming today.